Good morning, children. Welcome to the online classes of our Regina School. I am your Jagadish Master. Children, maintain social distancing and wear mask, okay, in order to be safe and secure. Chapter number 2, children. We already completed chapter number 1 and this is our chapter number 2. In chapter number 2, and particularly in this class session, we will study motion, relative motion, vector and scalar, distance and displacement. Okay, now we will see what is motion. This is the first page number 11 of your textbook, my dear children. Okay, now we will see what is motion. Okay, in order to study motion, first we need to know what is stationary object, that is not in motion. Stationary means not in motion. See, tree, your house, okay, street light or some monuments, they are always in stationary. That means they are not moving, their position is not changing. Then what about motion? A body is said to be in motion when it changes its position continuously. Okay, best example is here I am showing you a car. At before, now the position, how the, see, after 6 seconds the car is in position B, at position B. Initially the car is at A, now it came to B after 6 seconds, like this. See, the person initially at A and now he is at B. Like parrot also, see, it is changing. And also now we will see, my dear children, that is motion of the earth. When we are talking about motion, we should know the motion of the earth. See how the globe motion, earth is moving, that is globe, our globe earth is moving. So generally our globe has motion is of divided into two kinds, that is two types, rotation and revolution. What is rotation? Rotation is the movement of the earth on its own axis. What is the revolution? Revolution, the movement of the earth around the sun in a fixed path or orbit is called revolution. See, here I am showing you how the earth is moving around revolving around the sun. So while it is revolving or while it is in motion, my dear children, some part is faced by the sun and some part is hidden from the sun. So due to this motion of the earth or globe, day and night is happened. Okay, so the best example, now we are facing morning, but what about Americans? They are facing night. So now I think you understood what is motion. Now we will see relative motion, my dear children. See, here some children are being walking into the children's park. Okay, now my dear children, see, it is on a map. Now we are seeing, so when the children are walking on the left, where the park actually it is on the left side, but when they are coming from north side onwards, from the top side onwards, where the park it is right side. Park is at same place, but how the position is changed left and right? It is because relative motion, that is due to the frame of reference. In order to understand the frame of reference, we need to know the directions, my dear children. We all know that there are 4 directions: north, south, east, west. See here, the red t-shirt boy, where the cat is, he is, according to him, the cat is on right side. What about green t-shirt? According to him, the cat is on the left side, my dear children. Okay, now you are in the train. Best example, in order to understand much better, now you are sitting on the train, my dear children. You are in a railway station, you are in the train now. So while the train is moving, how the objects, see, buildings, electric poles, everything trees, houses, you are observing, okay, how they are. It seems when you are moving forward, how they are moving in the backward direction. Even you and your friend both sat in the train, okay. For you both, how the objects are outside, they are moving. What about the person standing on a platform? How for him you are moving, okay now see, in order to understand clearly relative speed, my dear children, white car is moving with 40 km per hour speed and red car is moving 30 km per hour speed. Both are moving in the same direction. What is the relative speed? 40 minus 30 equal to 10 km per hour. Children, here you need to understand one important thing, that is the direction of the both cars are same. In same direction they are moving, okay now. They are moving in the same direction. At that time the relative speed is taken as difference. You have to differentiate the relative speeds in order to find the relative speeds. Now see, for now white car is moving with 40 kilometer, that is same speed, and red car is also moving with the same speed, that is 30 km per hour, but they are moving in the opposite directions. One car is going to the left, that is white car, and red car is moving towards the right side. Now what is the relative speed? You have to add up the both speeds, that is 40 plus 30 is equal to 70 kilometers per hour. I think with this example you understood what is relative speed, okay na. In order to understand much clearly, we will see some relative motion of objects in our real life where we observed, okay my dear children. See, whenever you are traveling in train, at some points you will observe other train is also moving, okay. In a station, two trains are moving, okay, in the opposite directions. So now you are in the first train, my dear children. So see here, you are in the first train. So the speed of this train is 30 km per hour, okay. What about the velocity of other train? That is 60 km per hour, okay na. They are moving in opposite directions. What will be the relative speed? I already told you, when two objects are moving in with different speeds in opposite direction, relative speed is should be added up, okay. Now the other, you will observe the other train is moving with 90 kilometers per hour. That means 30 plus 60 you are adding, and how the other train is 90 kilometers per hour speed, it will move. You will feel like that, but actually it is moving with only 60 kilometers per hour, okay na. Now my dear children, see here, this is what relative speed. It is a general experience you will observe, my dear children, okay na. Now my dear children, in the case 2 we will see when both trains are moving in same direction, okay, with velocities v1 and v2 equal to 60 km per hour, with velocities v1 and v2. So in this case, from the frame of reference, that is from the observer point of view, that is you are in one train, that is first train. So when you are observing the other train, what it will be? 60 minus 60, 0. Relative speed of both trains is 0, okay. Now we will see, I think you understood well. Now we will see distance and displacement, my dear children. See, now you are at home, okay. Now you want to come to our Regina school. So what is the distance? You will say, suppose from your house to our Regina school is some 5 kilometers. What you will say? The distance from your home to our school is 5 kilometers. If you are far from our school, suppose you are 15 kilometers apart from our school, what you will say? The distance between our school and your home is 15 kilometers. That is distance. Okay, simply what is the distance? Total length covered is nothing but distance. Okay, total length covered is the distance. Okay, now my dear children, have you understood? See, here I am showing you from house to school there is a road. So you are traveling in that road through bicycle and you came to the school. So okay, now came to the school. Now what you will say? The total distance that you traveled through bicycle is nothing but distance. The total path that you traversed through your bicycle is nothing but distance. Okay, now some 5 kilometers. Here I am showing you in meters. 1000 meters is nothing but 1 kilometer. So my dear children, simply you can understood the total distance, the total path traversed is nothing but distance. So on the road from your house to school you came, it is some 50 kilometers distance, for example. Now there is a shortest path directly from your home to school. Okay, shortest path. That shortest distance or shortest path is nothing but displacement. Okay, now see my dear children, we have seen what is distance and displacement also. But distance is scalar or vector quantity? Okay, we need to know whether distance is scalar or vector quantity. Distance is scalar quantity. Okay, now in order to define whether it is scalar or vector, my dear children, you need to know what is vector, what is scalar quantity. Okay, I told you distance is scalar quantity, but how I am saying that distance is scalar quantity? So in order to know that, you need to know what is scalar and what is vector. See here, so I am showing you different directions. So that means a vector quantity has both direction and magnitude. Okay, both direction and magnitude in the sense, suppose from school to your house the distance is 5 kilometers. Now I am telling you 5 kilometers. 5 kilometers is nothing but distance. That is it has only magnitude, my dear children, no direction. Okay, it means, children, now see, we will see what is displacement. So displacement is nothing but distance with direction. Okay, so from your house to the school, till now I told you magnitude, that is some 5 kilometers, 10 kilometers, 15, like that. But in which direction it is? So where the school is located from your house, is it in north or south, east, west? If I am talking the direction, then it is a vector quantity. Okay, see, from house to the school is, where the school is 50 kilometers or 20 kilometers, that is magnitude. That means you are talking only about the magnitude, that is distance. What about the direction? So from the house the school is 20 kilometers, that is shortest distance. And where the school it is? In the north. So from your house to the school is in the north direction. From your house the school is in north direction, and the shortest distance from your house to the school is only 20 kilometers. That means we say that is displacement. Simply, what is displacement, my dear children? the shortest distance is nothing. Shortest distance traveled or traversed is nothing but displacement. So a displacement has magnitude and a direction. So that is why our displacement is a vector quantity. Okay now. What about distance? It is scalar quantity, that it has only magnitude but not direction. Okay, what is displacement? Magnitude plus direction. It is a vector quantity. Displacement means shortest distance. Okay, shortest distance with a direction. Okay now my dear children, I hope you understood what is distance and displacement. See, is distance and displacement are always different? Yes, based on conditions. See, in a straight line motion, the distance and displacement are same. They are equal, my dear children. See here, from point A to point B. So from I showed in arrow direction. What is the distance? 100 meters. What is the displacement? 100 meters. Is there any shortest distance here? No. In a straight line motion, remember, once again I am repeating, in a straight line motion, the distance and displacement are equal. Now see here, my dear children, when the displacement is 0 and distance is not 0, if we are moving in a straight line motion to and fro, that means, so see here I am showing you a car came to a particular point B and again it went back to the same point. Okay now, have you observed the video? See, now in this condition the displacement is 0, that is starting point and ending point is same, there is no difference. That means displacement became 0. And what about the distance? First it traveled 100 meters and again it came back, traveled 100 meters. That means while it is moving in the forward direction and it is moved in the backward direction, that is total distance covered is 200 meters. That is the total path it is traveled in to and fro motion. In both directions it traveled 100 plus 100, that is 200 meters. What about displacement? 100 minus 100, 0. Why? Displacement case, 100 minus 100, it is 0. Okay, starting point and ending point is same. Now in a circular motion we will observe what is displacement and distance, my dear children. See, I am showing you here a boy standing on the circular road, ring road. So he is running in the clockwise direction and reached the same point where he started. So now the starting point and ending point is same. Let us assume that the length of that circular road is some 100 meters. Now what is displacement? Okay, see here, 100 meters minus 100 meters, that is 0. Okay now, that means, my dear children, displacement is 0 on the circular road. On a circle, in a circle the displacement is 0 because the starting point and ending point is same. Okay now. Now what about distance, my dear children? Distance is nothing. When you are talking about distance, the length of road, that means you should not think of direction. Here you have to think how much length you covered regarding distance. So when you are talking about distance, you need to think only what is the length you covered. The total length you covered is 100 meters. Enough. What will be the length of the circular road now? 100 meters. Here I took 100 meters, but actually when you're talking about in a circular motion, when you're talking about distance, simply in a circular motion the distance is circumference of the circle, that is 2 pi r. Okay na? Here that 2 pi r is nothing but some 100 meters complete circumference. Okay, for your understanding purpose I took the length is 100. Okay na? What is the distance in a circular motion? Simply circumference of the circle. What about the displacement in a circular motion? 0. Why? Starting point and ending point is same. Okay children, I think you have understood what is motion, distance, displacement, relative motion, everything. Okay, thank you.